So Mike, all of the projects that you're putting up on your site are way too complicated for me. Can't you do just a simple transistor type project? I got one for you guys. How about something you can do over the weekend? It's not a 30-second project, but it's something that, just involves one transistor. How's that? One transistor. A simple code practice oscillator. So yeah, it's the classic code practice oscillator project. You guys have been accusing me of having projects that are way too complicated. Here's something you can do over a weekend. The simple code practice oscillator project, usually with just one transistor. Almost all of the old project books include this circuit. You're going to be able to get everything out of an old pocket transistor radio from the 60s or early 70s. So here we go. Let's even learn some Morse code. It's a simple code practice oscillator.
Okay, so you want to build a very simple first transistor project, and you want to actually hear something coming out of the speaker. I can't think of a better project than the classic code practice oscillator. We're going to build this together. First, you'll need to gather up a few parts. You're going to need a code key, of course, which you could also build. And why not learn the code with this thing? There are literally hundreds of circuits made from transistors, FETs, ICs, tubes, the 555 timer, even neon bulbs to make code practice oscillators. I've selected an easy circuit that lets a transformer do the work of both feedback and driving the speaker. The most important part in the very simple circuit is a transistor radio or amplifier, audio output transformer with a center tap primary that measures between 50 and 600 ohms DC, and a secondary that measures between a half an ohm and maybe 15 ohms on your multimeter. This is typically the red or green transformer in those old transistor radios from the early 60s and 70s. The blue transformer in those radios, by the way, is usually the interstage transformer or the input type rather than the output transformer. You really can get all the parts we need for this project from the same radio if you're lucky enough to have one in your junk box. After all, we just need a transistor, doesn't matter if it's NPN or PNP, a few resistors, capacitors, a volume control potentiometer, that's our tone control, a phone jack of some kind and a plug for the key, and of course a miniature speaker and that all-important 9-volt battery clip. Like I said, any old transistor radio should have all of these parts. Select a transistor near the audio output transformer and you really can't go wrong. It likely will be some kind of a PNP audio transistor. That's perfect for this project. Can you use an NPN silicon like a 2N3904? Yes, but you'll need to reverse the battery leads and adjust the bias potentiometer to get the tone range correct. Just to be flexible, I'll use a transistor socket in my breadboard so we can try some different devices and see how they work out. I even have some old Soviet transistors to try out. Okay, here's a rough parts list.
Okay, here's a few parts. These are all candidate parts for our little CPO project. I've got the transformer. This happens to be a green one out of a transistor radio, the 9-volt battery clip, and the holder. I've got a 250K pot. Now that's going to mean that the fixed resistor value will have to go up, but we'll adjust that as we go. The key jack, the transistor socket, a capacitor, a 0.1 or 0.22. We'll fool around with that and see how that affects the tone. And a few transistor candidates. Now I also have a 2-cell holder. We'll try running it on 3 volts as well and see if it still works. And don't forget we need a speaker and some type of a case to put this in. The enclosure or the case, of course, will improve the tone on the code practice oscillator. Just having a raw speaker on the bench is going to be pretty rough sounding. Okay, so this is a germanium transistor. It's a PNP. Got 9 volts. This is the equivalent of about a 12K resistor. I'm going to use a 10K there. And the potentiometer happens to be a 250K. It gives a decent range. I don't have a problem with that. So I'm going to replace the germanium transistor with a silicon 3904. Let's see what happens. Now it's interesting, the silicon transistor seems happier at 6 volts. When I go up to 9 volts, it seems to go into this ultrasonic oscillation, which probably could be tamed, but I think it's because it has so much extra gain. Yeah, so it's just got a lot more gain. Now, I did try these other transformers. They both worked. This is the typical green transformer you used to get in that Radio Shack kit that I'm using. Radio Shack used to sell this. I think it was like a 2000 ohm to 8 ohm type transformer. So again, it has similar resistance of like 100 ohm center tapped and less than an ohm on the secondary, but the silicon transistor seems to work. This is a pretty forgiving circuit.
So you may have guessed that this circuit is a Hartley oscillator, but it's not. Hey, but it has a center tap. Sorry, it's still not a Hartley. A Hartley oscillator, by definition, is a tuned oscillator that takes advantage of resonance to increase feedback at a certain frequency. A Hartley oscillator can produce a pure sine wave. This simple circuit is in fact a blocking oscillator, or maybe a pulse oscillator. The Hartley circuit's often referred to as a split inductance oscillator because the transformer is center tapped. In effect, the tapped primary inductance acts like two separate coils in very close proximity. Like all transistor amplifiers and oscillators, the impedance of the collector load is resistive. An increase in the base voltage causes a decrease in the collector voltage in a 180-degree flip fashion. Thus, with 280-degree flips, we get positive feedback. When the circuit is oscillating, the voltage on the collector relative to the center tap is 180 degrees out of phase with the voltage on the base relative to the center tap. So the center tap provides that first flip, and the transistor provides a second flip, just like with a Hartley oscillator. That's no different. But with this circuit, the amplifying element is cut off or blocked for most of the duty cycle, producing periodic pulses on the principle more of a relaxation oscillator. And a capacitor couples the oscillation into the base where it's discharged. A smaller RC means a higher tone in the charge-discharge cycle. So there's a charge-discharge cycle developed between the coupling capacitor and the potentiometer in respect to proper bias, and the transformer provides coupling properties that seem to smooth out a pretty rough square wave looking signal. And with the addition of our cabinet, the tone starts to sound okay. Now in normal code practice, we're looking for between 500 and 2000 hertz. So those higher harmonics don't really come through too much. Anyway, using very primitive transistors like PNP germaniums that have AC current gains of less than 2 in some cases, they work. They work in this very forgiving RC time constant blocking oscillator. However, if we stick a high gain, modern, high frequency transistor in the circuit, we may need to tame it. This can probably be done by increasing the emitter resistor value to degenerate the stage and lower its gain.
Okay, in the next video, we're going to tame this thing, get it into an enclosure, and try a few of these other transistors in the circuit. And hopefully we'll have a nice code practice oscillator as the result.